Hey there, and welcome to This Explainer. Have you ever just stopped and wondered, why? Why do the planets in our solar system trace such precise equations? Why can light, atoms, ocean waves, and even entire galaxies be described flawlessly by mathematical formulas? Think about it. Why do snowflakes have such absolutely perfect symmetry? And why does nature constantly repeat the exact same geometric shapes? Today, we're diving deep into the very fabric of reality to figure out why our universe seems bound by strict, unyielding math.
So we've got to ask ourselves a pretty profound question. Did we actually invent math, or did we discover it? Is it merely a human language, just some symbols and rules we cooked up to make sense of things? Or is it a hidden cosmic code that was here long before human beings were even around to think about it? Because, let's be real, the universe definitely doesn't read our textbooks, yet it behaves exactly as if it were written in the language of mathematics.
Let's kick things off with Section 1, Nature's Mathematical Hidden Order. Just look around us. It's totally wild that the exact same mathematical principles dictate the spiral of a shell on the beach, the crashing frequency of ocean waves, the steady rhythm of your own heartbeat, and, yeah, even the predictable spread of viral epidemics. Nature isn't just throwing things at the wall to see what sticks, it's highly structured.
Take this number, for instance, 1.618. You probably know it as the golden ratio, or phi. This thing is basically a universal geometric blueprint. Whether you're looking at the way leaves grow on a plant stem, the proportions of classical art and architecture, or even the structural symmetry of the human body, this harmonious ratio just keeps popping up over and over again.
And that ratio? It builds right into the famous Fibonacci sequence. You start with 0 and 1, and every subsequent number is just the sum of the two before it. It's such a simple, repeating rule, but it generates astonishing complexity, like the intricate spiral arrangement of seeds in a sunflower. It's incredible proof that nature's massive complexity is actually born from very basic mathematical logic.
Which brings us to Section 2, from planets all the way down to quantum atoms.
Historically, humanity slowly discovered this code over centuries. Back in 1609, Johannes Kepler realized planets don't move randomly, but in precise mathematical ellipses. Then in 1687, Isaac Newton defined universal gravity, showing that the exact same math pulling an apple to the ground keeps the moon in orbit. Fast forward to 1925, and brilliant minds like Born and Heisenberg were using complex matrix math to map out quantum particles. Slowly but surely, we realize the cosmos isn't chaotic at all. It's highly ordered. And when you zoom all the way down to the microscopic atomic level, things get even crazier. Physicists hit this mind-bending magic number, 137. Also known as the inverse fine structure constant, it doesn't rely on human measurements like inches or grams. It just perfectly dictates how light and matter interact. If this number was even a tiny bit different, stars wouldn't produce carbon, and life as we know it would be completely impossible.
Moving on to Section 3, the unreasonable effectiveness of math.
Nobel laureate Eugene Wigner actually coined that phrase during a lecture back in 1960. He pointed out something absolutely baffling. Pure math, concepts that mathematicians invented simply because they were beautiful and logical, without any physical real-world use in mind, somehow perfectly predicts physical reality years or even decades later.
And here is the wildest part of the whole shebang. We consistently get more out of the equations than we put in. Take the lowest energy level of a complex helium atom. Physicists used pure math to calculate it, and it matched experimental data to within 1 part in 10 million. Or the Lamb shift in quantum electrodynamics. The math predicted these tiny, super-specific atomic fluctuations with staggering accuracy, before experiments could even properly measure them. The math literally outpaces our physical experiments.
So naturally, this leads to Section 4. Is reality actually a computer simulation?
Because math works so incredibly, unreasonably well, researchers like Dr. Melvin Vopson suggest we might literally be in a digital simulation. And there are some compelling clues. First, quantum mechanics shows space-time isn't continuous. It's divided into fundamental Planck-scale chunks, kind of like pixels on your screen. Second, Vopson proposes a second law of infodynamics, observing that the universe constantly minimizes information, exactly like a digital compression algorithm saving memory. And third, gravity itself might just be a byproduct of this holographic system optimizing its data.
But hey, we need to stay objective here. It's a huge debate. While some folks see digital code everywhere, mathematicians at the University of British Columbia recently threw a massive wrench into the simulation theory. Using Gödel's incompleteness theorem, they mathematically proved our universe possesses non-algorithmic laws. Basically, there are fundamental truths in physics that no algorithm can compute, meaning it is theoretically impossible for our universe to be a mere computer simulation running on some giant hard drive.
If it's not a simulation, then what? Section 5. The mathematical universe hypothesis. Cosmologist Max Tegmark proposes a really radical take called the mathematical universe hypothesis. He argues we need to stop thinking of math as just a handy tool we use to describe things. Instead, he proposes that mathematical existence and physical existence are literally the exact same thing. The universe doesn't just have math in it, it literally is a giant mathematical structure.
The implications of this are absolutely staggering. If this is true, math is an external, objective reality. We aren't inventing it. We are simply self-aware substructures living inside a massive mathematical object. We're just discovering the architecture of the house we already live in. And honestly, that beautifully explains why our physical laws are so elegant and simple, because the universe is fundamentally built on logical, decidable mathematical structures.
Let's wrap things up with Section 6, Discovering the Cosmic Code. So, what should you take away from this explainer today? Reality is a symphony of order. Whether you look at the perfect hexagonal symmetry of a falling snowflake, the neat categorization of the periodic table, the repeating fractal patterns in rivers and lightning, or the unbreakable universal laws of energy conservation, it is crystal clear. Our reality emerges from a deeply connected, non-random order. And perhaps the most amazing fact of all isn't just that we can use math to build bridges or launch rockets. No, the true miracle is that the universe actually allows us to read its hidden code. Through mathematics, our human minds are somehow capable of grasping the deepest, most fundamental truths of the cosmos. The mathematical order of reality is an endless, absolutely fascinating mystery. If you want to keep exploring why math perfectly describes everything around us, and you want to join us on this journey to decode reality, make sure to subscribe to the Universe Code. Thanks so much for watching this explainer, and always keep questioning the reality around you.